I want to go through some of the review problems from the pre-response just to make sure that you've done those correctly. As I looked through it, I saw some mistakes that I want to make sure that you're clear on before you take your test. So this first one, and I'm not going to go through every single part of all these problems, but just kind of give you an idea and remind you about how you might attack some of them. But on this first one, I talked about the survey. They classify these different companies based on their size, small, medium, large. They selected 200 randomly, or they had 200 randomly selected businesses of each size. Because all the questionnaires were returned, they looked at the relationship between the response rate and the size of the business. So the data was given in that two-way table. So the first thing you want to know, okay, which one's the explanatory? Well, remember the explanatory is the one that would be like on the x-axis. It would be the one that would affect the outcome or affect the output. So the question was basically, if they answered yes or no, would that affect how big they are? Or would how big they are affect whether they answered yes or no? Or whether they actually responded yes or no? So the explanatory variable really would be the size. Because most likely a larger company might possibly not pay attention to this questionnaire versus a smaller company. Maybe they would pay more attention to it. It's kind of what it looks like. All right, but the size is going to affect whether they respond or not. Then the segmented bar chart. Again, I'm not going to draw it all out, but remember what you want to do is you would want to base it off of the sizes in this case. So for instance, if I look at the small companies, I'm going to find what percentage answered yes. So I take 125 divided by 200, I get 62.5, which would leave me then with the rest of them, or 37.5 being no. And so when you make your segmented bar chart, you'll go up to 100 to create your entire bar here for the small class, small business. I'm going to go up to the 62.5, and you want to choose, say I went by 10s here, so 10, 20, 30, 40, 50. So we'd be looking at about right in here for the yeses. And we'd want to designate that somehow, maybe with stripes or coloring it in, something like that. And you do that for all the different sizes, but don't forget, you want a key then. So for mine, I made the stripes yes and the open part no. So you do that for each one, and that would be your segmented bar chart. You'd want to make sure that you had a title of some sort, depending on what you want to call it. Then for part C, they want to know, okay, well, is there an association between the size of the business and whether they replied to the survey or not? Well, the answer to that question is based on, did I get the same result for each of those different sizes? For instance, we said small had 62.5% that said yes, medium had 40.5% that said yes. So since they didn't have the same percentage, that tells me, yeah, there was an association. If all those percentages came across 62.5, 62.5, 62.5, then there's not an association. But in this case, yes, there is an association. And again, that's because those percentages were different. So I kind of reviewed what we talked about in the first section of chapter 2. The next one started talking about what we spent most of our time on. The scatter plot there looked at the heights of different players for the Brooklyn Nets and their field goal percentage. And they asked us to describe it. So remember, when we describe it, there's 4 different ways we're going to describe it. We're going to describe it by the direction, which looks like this one's going to be, and it's not really sharp as far as the increase, but it looks like it's going to be a positive. We're going to describe it by the form, and on this one it looks pretty linear. We're going to describe it by the strength, Now, we don't have an R value on this one, and we don't have specific data points to help us find the R value. So we're going to basically just decide whether it's strong or weak. This one's fairly close together, so we'll call this one strong. And then remember, we want to look for, are there any outliers? Well, don't really think that there would be necessarily an outlier if I kind of drew a line through these values. Maybe this one out here would be considered an outlier. It's a little bit further off. So if you said there was that one outlier, maybe that would be okay, but it's kind of borderline probably for an outlier. All right, then they wanted us to actually find the regression equation, but they didn't give us, again, the actual values for each player. They gave us the mean, the standard deviation, and the correlation, or the R value. So we had to use our formulas to help us here. So we're going to find, first of all, the slope. And remember, the slope is the R value times the standard deviation of Y over the standard deviation of X. Well, the R value would be the correlation, so that was 0.59. The Y values were the field goal percentage. So if we look at the standard deviation of the field goal percentage, that was 7.1. The X values were the heights, so the standard deviation of height was 3.29. So I'm going to punch that in and see what our slope was. And I get 1.27 for the slope. Now the y-intercept. So the y-intercept, we said we're going to take y bar minus that value we just got for slope times x bar. So y bar would be the field goal percentage mean. So field goal percentage mean was 45.3. Our slope, or b value, was 1.27, we found. And then x bar, the height had a mean of 78.9. So again, I'll punch that in. And that's negative 4.90. So our equation here, when we put that together, we'd say y hat equals, and you can write it different ways, but I'm going to write it as negative 54.9 plus 1.27x. So that would be our regression equation. All right, then the last one. On the last one, they gave us some data. They asked us to make the scatter plots. Remember, when you do your scatter plots, make sure you have your labels on there. Make sure you have an accurate scale for the x's and for the y's. In this case, the age would be x, the height would be y. All right, then using technology. So for on your calculator, once you punch all those values in, remember we're going to go to stat. We're going to go to calculate, and we're going linear regression. So for this one, when you did that, you should get this for your prediction equation. Y hat is equal to 71.95 plus 0.38x. So that would be your least squares regression line. Then they wanted us to use that to make a prediction for someone who is 40 years old, or in other words, they were 480 months. And then we want to convert our prediction to inches, which right now it's in centimeters. So first of all, let's just plug in the 480. So we have y hat is equal to this. And if I plug in 480, that'll give me my prediction. My prediction is 254.35, and right now it's in centimeters. Well, we know that 2.54 centimeters is equal to 1 inch. So I need to convert that because they wanted us to put it into inches. So to convert it into inches, I'm going to divide by 2.54 because that would eliminate my centimeters there. So if I divide it by 2.54, I get 100.14 inches, which is really a little over 8 feet tall. Well, why is that prediction so impossibly large? Well, the reason is, if we think about that 480, that's way outside of our data range. The highest value we had for age was 60. So remember, we want to stay within our data range here, because if I don't, then I'm going to be looking at, like this one, I'm going to be looking at a result that doesn't really even make any sense. So that was outside of our data range. And that's why I ended up with something that didn't make sense. All right, so hopefully that helps a little bit with some of those that you had to do for the review.